English very well, so
Okay.
Yeah.
he can talk to you without his.
Не, подожди, не уходи.
So pretty much excited about this NMM and senescence story you
Yep.
mentioned yesterday. So since I'm just involved in cancer research, right, for a long time, so I'm just wondering the impact of NAD for the cancer growth, right? Because of course you can eliminate senescent cancer cells which are undergoing to senescence after the DNA damage, right, by chemo and radiation. But at the same time, there will be some kind of papers indicating that NAD can stimulate the cancer by the preclinical models. So just wondering, so do you have some kind of doing some kind of studies in this particular area?
So the only thing we've done in this study is we took the H-Pro formula and we looked at. So we have an assay that we do we've been doing it for years.
Okay.
It's the same assay where we looked at old immune cells versus young immune cells.
Yeah.
And in this, the health threat, the immune cells that are going after the health threat is a leukemia line.
Okay.
And normally with transfer factor, we see about a 20% kill rate, which is good compared to, because IL-2, which is the standard of care, is usually anywhere from 10 to 15%. So we see a better kill rate than the standard therapy.
And tons of side effects of IL-2, systemic use, right?
Yeah. And so I literally got this data, so we need to repeat it. It's preliminary data. But we looked at the whole formula of H-Pro, and the kill rate, and we had transfer factor there, we had NM in there, the kill rate of the combination of all those ingredients was over 90%.
And this is both preclinical studies, right?
This is ex vivo.
Ex vivo.
Yeah. So we take PBMCs and we treat those PBMCs with sample, test article, formula, and then we put them in the presence of the K562.
This flow data you
The
mentioned.
standard model, right? You know this model. It's standard.
Okay.
So this is just ex vivo, right? No clinical, no preclinical. And in that study, with that formula, we saw a 90+% kill rate. Where TF, transfer factor, alone is around 20%, 19 to 20%.
Oh, that will be synergy between these.
So there's additive or synergistic benefits going on.
Okay.
Yeah.
Awesome.
And we know, we actually also did NMN by itself, TF by itself, and those give, so NMN by itself doesn't do very well. It's only about 6%. But when you put TF together at lower concentrations, so we studied it at 1:1 and at 0.5 to 0.5. So 1:1 shows you additive benefits. 0.5 to 0.5 gives you synergistic benefits. And at 0.5 to 0.5, we were seeing a greater than 20% kill rate. So we know at lower concentrations to get above TF and above NMN that we're getting synergistic benefits. And that's just TF and NMN alone. When you put all of them together, they go to 90%. So it's likely they are synergistic benefits. But we haven't looked individually at each ingredient by itself.
Okay.
Only TF and NMN, and then the whole formula.
Okay, and did you study about the synergistic between traditional medicine? I mean, the chemo and radiation? No, just
Yeah, I mean, we just look at IL-2. IL-2 is the gold standard for this, and so we always compare to IL-2. We always run TF, and then we look at other ingredients to see if we get any benefits, any synergies. So
this is my interest because we have the cancer lab in Russia, right? So and I have my own lab, right? And we do these synergistic studies.
you do xenografts?
Yeah, we have a mouse facility and nude mice and all this stuff.
So you should take some back and try it, see if it works.
Yeah, so this was the idea. So we can just do some kind of studies and if it works. So
Because I haven't seen anybody doing xenograft models. Of course, there's this whole idea, this whole theory of if you can use NMN and these types of senolytic ingredients, you course, you're going to reduce inflammation. Inflammation is the precursor to cancer and cardiovascular.
Thing also.
So if you can treat it early, so that you can reduce all these hallmarks of disease, then perhaps you can, take a proactive approach. But nobody's tested that in xenografts. So I would love for you to take some product back. I will give you product. Take it back and try it in the xenograft models and see what happens to the tumor. Does it continue to grow?
Shrinks a bit.
Does it shrink? Does it stop?
And we can do all the pathology, right? Do these hematologic stain or immunohistochemical study to measure the proliferation.
Right. Yeah. See, I used to do this before I came to For Life. I worked in an oncology discovery company, so I was in charge of doing the xenografts, the pharmacodynamics, the PKs.
Okay.
And so we used to do these, but we were using protein kinase inhibitors. That's what our discovery work was.
Targeted something.
Yeah. Target. So we had an ALK2. We had a JAK inhibitor. We had a PIM inhibitor.
I mean, LK, like quercetinib, so
small molecules. Yeah. So we had a technology that allowed us to take the crystal structure and find the pockets, and then bind in those pockets to hopefully prevent it. So we had really good success preclinically in a lot of our xenografts models. We went into the clinic with some good models in the clinic, and then it was a small company, and then they sold to a bigger company, and so I had to go find another job. So that's what brought me to For Life. So I take that knowledge, right? But we can't do xenografts at For Life, right?
Yeah.
But I suspect, I would not be surprised if we give you that formula, give you that product, you put it in your xenograft models, that it will either reduce or it will stop tumor growth. I would not be surprised.
Okay.
So be an interesting study to do.
Yeah.
Of course, we could never talk about it, right?
Yeah.
But we would know.
Yeah, that's nice. So we can publish, right? I just have a lot of publications, MDPI, and you got these publications of the gold factor recently, right? So
So we actually submitted to MDPI for the Age Pro Science.
What kind of journal? Cancer?
No. It's MDPI. It's a special issue around aging and immunology. So perfect special issue.
Perfect fit.
Yeah.
Okay. So how we can push this product together? So because I'm leaving tomorrow, I'm being staying here. So you can ship this, or I can just.
Let's work with Tyler.
Okay.
I'll say, Tyler, let's get some product to you so you can do these studies. Now, of course, we can't sponsor it, we can't pay for it. We can give you product, but we can't pay for it, we can't sponsor it.
Yeah,
you can publish it, you can't mention For Life.
Okay.
But it's just good for us to know.
Okay.